Pretty easy.
Okay. So have you guys opened the quiz thing yet? The group one?
I haven't
Yeah, I
taken
just
it.
opened it.
Oh, you did? Okay.
So we're working on number 3?
Yeah.
Okay. So it says the human blood can be classified into one or of our basic types, O, A, B, and AB. The proportion of blood of people in the population of the United States with each of these blood types is summarized in the following table. Use this data to answer the following questions. So 3. The blood types and the proportions given in the table above define a probability distribution.
I put true.
Okay. Well, what's that even mean, a probability distribution?
The probability distribution. Hi, Nicholas. We just started on the homework, the quiz.
Okay.
We're just on a question 3. It can't be negative, and it has to add up to 100, and it has to be less than 1 each, like, probability.
So does this add up to 1? Did you do the
Yeah.
math? Okay, awesome.
So I just put 2 on that.
Perfect.
And then for 4, it says, what is the probability that a randomly selected person in the United States has type 0 blood, type O? I put 0.45 because that was just the proportion of it. I think that's how you do it.
So, yeah. Yes, I agree.
Because it just adds up to 100, so I guess you could say it's 45%.
Yeah, but it's 0.45 over 1, so it'd just be 0.45. You're right.
You guys get that?
Yeah.
Sorry, I just got it pulled
so.
up. Yes.
Okay. Let me know when you guys want to move on.
So, are we all together again, or not?
What?
Are we all on number 5 now?
I'm ready. Are you guys ready?
Yeah.
Yeah, I think I am too.
Okay, so it says, what is the probability that a randomly selected person would not have type type O? So I just subtract 100 from 45,
Yeah.
0.55.
Yep.
Yeah.
Okay. And then I didn't get answers for 6 or 7 yet. So. I guess I'll just read it. It says, Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tingle, one of the dogs, demonstrates the identification of a specimen. 7 bowls contained urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following questions. Okay, 6 says, if the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient?
So would that just be 1 out of 7?
Yeah, that's what I was thinking.
Yeah, I think so.
So 0.143.
Yep.
And to the nearest 3 decimals, okay.
Okay, so do you want me to move on?
Yeah, I'm ready.
Yeah, yep.
Okay, if a combined total of 52 trials, the dogs correctly identified the specimen from the cancer patient 22 times, it is very unlikely that the dog would do this It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most accurate? There is little evidence that dogs can detect bladder cancer. This proves strong evidence that dogs can detect bladder cancer.
I think that one would be that it provides strong evidence that it can.
Because it was able to do it 22 times.
Yeah. And like the second sentence just says it's very unlikely that this happened by random chance.
Okay, that makes sense.
So we're going with this provides strong evidence.
Yeah. I mean,
Okay.
I don't know. I assume that's right, but
Yeah, I don't know either.
okay.
It just makes sense, I guess, just by the wording in the sentence before it.
Yeah.
Okay. All right.
So M&Ms are small chocolate candy. Okay, whatever. Can skip that part. It says, for 8, if you reach into a bag of plain M&Ms, what is the probability of drawing a red color candy? I got 0.13.
Yep.
Okay. And then for 9, what is the probability that a randomly selected candy is green? I just add them all up and subtracted, and I got 0.16.
Yep.
Just make sure.
And then 10, you just subtract it. Subtract them all from 1.
So you got 0.84.
Yeah. So 0.16. And then for 10 is what is the probability that a randomly selected candy is not green? So 0.84.
Yep.
Okay. So for 11, it just says like it's a chart of like ECT scores. 11 says half of the observations are less than or equal to what number? Would that be the median?
Yeah, I would say that it's the median.
Yeah.
So 24?
I think so.
Sarah, is that what you think it is?
Sorry, I keep skipping. We're on 11, sorry.
No, you're fine. Yeah, we're on 11. Okay, so I guess it's 24. Based on the so 12, based on the information from the table above, the top 25% of the students scored above what number? Is that saying, like the top 25, is that saying like, Q3 or Q1?
I think that's Q3.
I think it's Q3 because they scored above that.
Yeah.
So, like, you'd have, like, the super smart students.
Yeah.
So, like, 27?
Yep.
Okay.
Yes.
And then for 13, which of the following statements is not one of the 3 rules? It's if the probability is high, then the probability is positive. Because the rules, I looked up the rules and I'm pretty sure that was it.
Yep.
Yeah, it
That's
can't
the
be a
same one I have.
negative.
Okay.
Yep. Because it's just 0 to 1, so there's no negative ones.
Okay. Well, we kind of blazed through that real fast.
Yep.
Does anyone have any questions, or do we need to go over any answers again?
Should we just run through them real quick to make sure we got them all the same?
Yeah. 3 is true. 4 is 0.45. 5 is 0.55. 6 is 0.143. 7, this provides strong evidence. 8 is 0.13. 9 is 0.16. 10 is 0.84. 11 is 24. 12 is 27. 13, if the probability is high.
Awesome.
Okay. I'm going to just submit it and see what we got.
Me
We got
too.
100%.
Yes.
That works for me.
Awesome, and that was fast.
Yeah, that was like very fast. So I'll just
Wow.
post the link in the group thing again.
Okay.
Oh, thank you.
Yeah, no problem. Thanks for meeting. So Thursday at 6:30 again, right?
Yep, perfect.
Okay, sounds good.
All
Alrighty.
right, we'll see you guys then.
See ya. Bye.
Bye.
Uh,